You may have noticed that when I wrote and I made kernel maps, I was writing 00011110. And many of you probably were thinking, well, why? Why doesn't he write 10 here, then 11 here? Well, the reason is simple actually. So let's start with this. Counting like this, so 00011110 is actually gray code. The gray code is necessary because, and it's very efficient because it only changes one bit at a time. Why do we do that? Well, let's suppose that you are not just in a construct, but we are in the real world, and that we have two inputs. Those are both 0. Okay, those are both 0. Then the first one goes to 1. And it does like this. This one is still 0. Okay, so far so good. It's fine. What happens if I do something like this? What happens? Let's just put this in this way. Okay, I just put my code, my normal code. So 0001 10 and then 11. But I'm interested in this step. Okay, so let's suppose that we have we call this A and this B. So this is A, this is B. If I wrote that, I have A, which is a 0, and B, which is currently sitting at 1. Okay. And then I have that A actually has to go to 1, and it does it like this. And B has to go to 0. But notice what happens. In a real world, they don't go and change at the same time. You expect them to change at the same time and A to become 1, okay, and have a step, and B to become 0 and have a step, but they don't change at the same time because, I don't know, for instance, the time in which they have to change, which is t here, is the same one for both, but they don't because, for instance, B is running at, I don't know, 22 degree, and A instead is extremely overheated and it's running at 97 degree. So different temperature, different behaviors, and A changes slightly later. It has a delay. Now, sure, in the end, we're gonna end up with something like this, which has 1, 0, which is our desired configuration. This is A is 1 and B is 0. But here, just notice here in this slight delay, okay, in this delay, we have something that it's not good because we have that A is 0 and B is also 0 because it already switched. So we don't want that because we would have something like 0, 0, 0, 1, 0, 0 for just a tiny bit, and then 1, 0. But this one could be triggering something, like something else inside our circuit. So this is actually very, very dangerous. The reason we do avoid this is that it could really trigger other undesired things because, you know, it's a logic circuit, so it behaves and it does certain things based on logic, So for instance, it detects that in this bit it's 0, 0 just for a little bit of time, and it asks something else like, I don't know, another AND gate, and the signal goes there and something bad happens. So we use gray code. Gray code, if you noticed, changes only one bit at a time. So 0, 0, 0, 1, 1, 1, 1, 0. In this case, we go from 0, 1 to 1, 1, so only A is changing. And then from 1, 1, we go to 1, 0, so only B is changing. And therefore, we avoid this mess because the one stays constant and the other one changes. So does it change at the exact same time? Doesn't matter because the other one is always the same. So if it's changing with a slight delay, does it really matter? So how do you write gray code? Well, let's start with this. So gray code. Yay. So how do you make gray code? Well, let's start with this. You start with the first two. So you start with 0, 1. Okay. And this is your starting point. Then you rewrite 0, 1. And you put here a mirror. Okay. This is just a mirror. Okay. This is mirror. And you put, okay, it's mirror, so you have 1, 0. Okay, then you do the same thing. You put the same thing you had, so 0, 1, 1, 0, and you put the 0 here and the 1 here. And you can do the same thing again and again and again and again. So for instance, you go on and you have 0, 0, 0, 1, 1, 1, 1, 0. Okay, because you have put this. And then you put a mirror here and you have the same thing. So essentially, you will have 1, 0, 1, 1, 0, 1, 0, 0. And do you want to go on? You can go on. You can have 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0. You kind of put the mirror for the first two. Okay, so the mirror is up here, and you just change and invert this from 0 to 1. So you have the mirror here, so 1, 0, 1, 1, 0, 1, 0, 0, because it's the effect of the mirror. And then here, from 0, you just change all of them into 1. You can go on over and over again into making gray code. So gray code is great because it avoids these ambiguity here. Because, you know, components, yeah, they should be at the same temperature, but they're not. There are many components inside, like complex circuits like CPUs and so on. So you don't want these ambiguity here. So yeah, this is exactly why we use gray code.